Hi everyone, welcome to today's class. Yesterday we talked about tables. We created a basic table. We also talked about the different type of objects that we are going to talk about in SQL Server. And other than that, also we talked about the different about the files. What are the minimum files that are required when a database is created? That means we talked about the data file, log file, and all of that. Today we are going to start with the one of the most important terms, which is database schema. And the other thing that we are going to talk about is the integrity constraints, right? So let's first of all understand what is the database schema, and then we'll go from there. So beginning with SQL Server 2005, Microsoft introduced the concept of database schemas. A schema is now an independent entity, a container of objects distinct from the user who created those objects. Previously, the term user and database object owner mean one and the same thing, but now two are separate. What was happening before 2005 is that there was no concept of a schema, but after 2005, we now have the schema. What is the purpose of schema? Why SQL Server or Microsoft brought this concept called schema? The reason for that is that before 2005, all the objects were actually directly tied to the user. Instead of having a container named as the schema, we had the user at that time and everything was tied to that user. The problem with that was, suppose that you are a right, you are a person working in a company, right? And you are creating your own objects and all. If you don't have a term named as schema, what would happen is that the objects that you will create, it would be bound to you only, right? And when you are leaving the uh, company, then transferring the ownership of those objects to someone else will become a challenge, right? How do you transfer the ownership of that object to someone else? And that's why we have a term now, schema now, because now the objects are not directly bound to the users, but they are bound to the schema, which actually holds the object now. And then we as a user get the permission of the schema. So now that actually makes the transfer of ownership from the schema or from one user to another user very easy, because now you have to transfer the ownership of the schema. So let's talk more about that to understand it. For example, when you create the table, in whichever schema you want to create the table, you'll put that schema here. So create table, my schema dot my table. By default, SQL Server has a schema known as DBO, right? So if you don't create any further schema, by default, there would be a schema already present. That is the default schema in SQL Server. And the name of the schema is DBO, or the full form of that is database owner. That can definitely be changed. That means you can definitely change the default schema. You can create your own schema, but by default, Microsoft provides one default schema in the SQL Server system. Now, this separation means object and schema can be created before users are added to the database. It also means users can be dropped without specifically dropping the objects owned by that user. A schema can only be owned by one user at a time, but a single user can simultaneously own many schemas. So what we are trying to say here is that now the schema and the user both are not the dependent entities, both have become the independent entity. That means when you create the database, after that you can create schemas. It's not important for you to create the users, because the schema is the thing that is going to hold on the objects, not the user. And also, if you want to drop any user, that means if someone is leaving the organization, then it is not directly proportional to the schema it is holding or the object. You can simply drop that user and all his access would be gone. But before 2005, the problem was that everything was directly tied to the user. Now, there was no concept of schema there. And that was causing a lot of issues in terms of holding of objects or transferring the ownership of objects. Talking about the default schema, as I said, we have by default the DBO schema in SQL Server that can again be changed. And we can also create new schema and we can create the objects in that new schema. That all is possible. But by default, SQL Server or Microsoft provides a default schema, which is the name of the schema is DBO. What are the implications of this term? The ownership of schema and owners and schema owned objects is transferable. Objects can be moved between schemas. A single schema can contain objects owned by multiple database users. Multiple database users can share a single default schema. A database user can be dropped without dropping objects in a corresponding schema. These are the various implications of having the schema in place. We'll learn more once we do the practice of schema. Once we create the schema, then also we'll understand more concept of it. And also once you scroll through the AdventureWorks 2019, if you have not installed it yet now, today I'm going to send an email with the instructions of installing it. So don't worry, you will install it today if you have not done it yet. Okay. So what is the advantages of using schema? As I have already talked about it, now the objects can be manipulated independently of the user. That is one of the most important advantages of using schema. Managing local entities in one physical database. What does it mean? That means in one database, you can define, for example, 10 different schema. And then in each schema, you can create 10 different objects. So that way you can actually create the logical separation of all these objects. Though physically, they all exist in the same database, but logically they can be separated out from each other. And again, schema adds an extra layer of protection, or if it's a type of container, so that is also adding the object protection. Now let's see with the example of this AdventureWorks 2019 that what is the concept of schema here. So let me expand this and go to the table here, right? Now you can see there are some objects in the DBO schema, right? This is the DBO schema. So where we have some objects, right? After that, what you see, there are some objects in the human resources schema. This is the, whenever we create the objects in SQL Server, or the objects are displayed in the dot notation. So every time whenever you see the objects in this file explorer, what you will see is that you will see the schema name dot object name. Okay, the object would not be coming alone, but it would be coming like schema name dot object name. So that's why it's like human resources dot department. It means human resources is the name of the schema. Again, we have the person schema as well. Then we have production schema. Similarly, we have purchasing schema. We have sales schema. So all these objects are existing in the AdventureWorks 2019, but they are getting separated, logically separated with the help of schema. And finally, the objects are being held by this container known as schema. If I want to see what are the different type of schema that we have in a particular database, there's a query that also you can write. That is self start from sys.schemas. And if I run this, I'll get information about all the schema that we have. Any schema which is principal, which is there with the principal ID 1, that is the schema that is actually being used by us as the user. So whenever you are trying to get the schema, you have to put this condition as well, where principal ID equal to 1. So these are the different schema that we have, we are using here. And suppose that if I want to create a object or any table or something, suppose that let me give you example here. So create table, maybe customer details, customer ID, and name varchar 20 address varchar, and right. Now, if I am going to create this particular table, can anybody tell me in which schema this table would be created? Anyone has any idea?
Human resource.
Okay. Why? Okay. Anyone else wants to answer this one?
Anu, can you scroll a bit up, please? Thanks.
It's already
Oh, so you took that off, right? Like you put the principal ID is equal to one, like
yeah, that is gone. I
yeah,
have
okay, okay,
removed
okay,
that. Okay,
okay,
you
okay.
if you want to
Oh
see
yeah,
that,
yeah,
this is
okay. So since we have not mentioned since we have not mentioned anything, it would go to default DBO, right?
yeah, that's correct. So basically, what is the thing that will happen here is that now again we can't say that it would go to DBO or it would go to anyone, but again by default the default schema is DBO, but again that can also be changed. We can change the default schema as well, but here I have not changed that, and that's why when I'm not mentioning any particular schema here, it will go to the default schema, and whatever would be the default schema of the database, in that it would be created. And for this particular case, it would be the DBO. Definitely that is correct. But again, the proper answer for this would be it would go to the default schema of the database, and whichever you have kept, like, right, because I have not changed it, so it will go to the DBO. That means if I create this, it will go to the DBO. For example, I want to create this in the human resources schema. In that case, what I need to do is that I need to put human resources dot customer detail. Now, once I do that, when I create the table after that, this table would now be created in the human resources schema. Now I have one more question here. Here you can see that we have a customer table already here in the DBO schema. Can I create the same table here in the human resources schema? Let's see that. You can see that this command got completed successfully, and if I refresh this table, what I'll see is that we have this customer here, right? In the same way, we have this customer here as well, right? So this is another benefit of having the schema in place, right? So basically, you can create the same objects again in different schema. If in the same database, I want to create in the DBO schema two tables with the name customer, that is not possible. But again, if they are part of different schema, it is possible. They can also have the different column names as well. In it, all the structure can be different. Sorry. As you can see here, I have three columns in this one that I have just now created. Here I have just two columns, right? So one thing that I would also like you guys to go through is that today I'll send you the link to install this at AdventureWorks 2019. Once you do that, you have to right click on the database. You have to go to the properties. Once you go to the properties, you have to go through all the different things that are here, all the different tabs, and you have to try to understand if it is making sense to you, right? All these different things that are there, right? You can see that there are lots of properties here. Some of the properties are definitely advanced one, so we don't need to worry about all of that. But again, try to understand and try to see how many of you can understand actually, and let me know if you have any questions in that regard later on. Okay, so that is what you can say that one of the maybe the basic assignment that I want to give you. Just try to go through the properties of this database. Now let's move forward and let's talk more about the other terms. The second term that we want to learn today is the data integrity constraints, right? I hope schema is clear to everyone. Anyone wants to ask any question? Okay. So talking about the integrity constants in SQL Server, there are 4 different divisions of integrity constant that we have in SQL Server. One second. Okay. So the first one is the entity integrity. Second is the domain integrity. Third is the referential integrity. And fourth is the user defined integrity, right? Now, let's first of all understand that what is the data integrity and what is the data integrity constant. So data integrity validates the data before getting stored in the columns of the table, right? For example, if an employee is entered with an employee ID value of 1 to 3, the database should not allow another employee to have an ID with the same value, right? So basically what I'm trying to say here is that data integrity actually controls the value that you're inserting into the columns or the tables, etc. So that is one of the most important concept, which is actually handling the type of data that can be stored in the column. For example, if you remember yesterday when I was creating the tables, I was specifically talking about the data types of all this, right? So somewhere down the line, these data integrity constants are also related to the data type that you are selecting for a particular column in the table, right? And again, every column has some distinct property. For example, in the employee, for example, suppose that you are working in a company, right? Now, in a company, definitely they are tracking that their total number of employees and everything to in some database table. In that database table, suppose that there are multiple people with the same name. Suppose that there are 10 different Anups who are working in the same company, right? So what is the way through which they can actually track all these different Anups? So everyone, whenever they join a company, they get an employee ID. And that employee ID actually is actually unique to everyone. And that's how they actually know, okay, this is this Anup, this is this Anup, and accordingly, everyone have different salary, everyone have different job responsibilities, etc. Right? So employee IDs is something which is actually taking care of uniqueness of each of these records. If there's no uniqueness, definitely what will happen is that someone's salary would get transferred to someone else, because again don't know which Anup is which, right? So to make sure that there's uniqueness in that particular column, we put up the integrity constant or the data integrity constant there, and that can be of different types. As I discussed, it can be either in entity integrity, domain integrity, referential integrity, and then after that we also have the user defined integrity, right? So here we are talking about one of the different data integrity constant. That means the employee ID has to be unique. Otherwise, we won't be able to make sure that if all of these records are unique, and we not be able to identify all different Anups that we have in the system, right? So I hope that makes sense. Now, the second is the entity integrity that we want to talk about. So we in terms of data integrity constant, we have the 4 different integrity constant here. So we'll talk about each one of them. Just now I gave an example, a particular example of the data integrity constant. Now we are going to talk about all of different types of data integrity constants now. So the first one is the entity integrity, as I said. So entity integrity defines a row as a unique entity for a particular table, right? So entity integrity enforces the integrity of primary keys of the table through indexes, unique constant, primary key constant, or identity property. So through using the entity integrity, we make sure that we either have the uniqueness in the records, or we are defining the identity column property through which also we are making sure that we have unique record for each of the different columns and things like that. So this entity integrity constant makes sure that you are able to track each unique records in the table. It can be either through the unique constant that you can define on the table, it can through the primary key constant, or the identity properties, right? Once we are done with understanding all these four different type of integrity constant, then we'll do the example of the same. Like we'll try to understand more about unique key, primary key, and all. Though later on, again, we'll have a separate class on all these different things. But as of now, just we'll try to understand some part of it. Talking about the domain integrity is the validity of entries in a given column. We can enforce domain integrity by restricting the type. So through the data type, we actually restrict the type of data or the size of data that can be inserted for a particular column, right? So that is an example of the domain integrity. For example, you define that the employee ID has to be integer. Now, suppose that you want to insert any character in the employee ID, that is not possible, right? Why it is not possible? Because we have defined a particular data type for the employee ID already. So either you have to change the data type or you have to insert only the integer value, right? So that is just like enforcing a domain integrity. That means what is the domain of values that can be inserted for this particular column. The other thing is that also we can again further restrict that what is the domain of employee ID that can be inserted for that employee ID column. For example, we want to make sure that the employee ID has to be greater than 1000 and it has to be less than 10,000, something like that, right? So that can be done using the check constant that we have, that is again controlling the domain of values that has to be inserted for this employee ID column. Again, we have other type of constant as well, like not null constant, which will actually make sure that you're not inserting null values in a particular column. Then you can have the default constant as well, which will make sure that if you're not inserting any value by your own, SQL Server will take care of that and it will insert a default value whatever you have given, right? So there can be different type of domain integrity constant, but the main thing here is that the domain integrity constant, it will take care of the range of values that can be inserted for a particular column. In the same way, the foreign key constant. Now, foreign key constant is a very important constant that is used to take care of the parent-child relationship. For example, you have created this employee table, right? Now the employee table has the employee ID from 1 to 100. Once you create the foreign key constant in another table, that means suppose that we have another table known as employee department, in which we have this employee ID column. Now that employee ID column in the employee department table, it can it, it can, because we have already created the foreign key constant here, that means it can be only be this range of values that we have in the employee table for this employee ID column. Now, if
Sorry, Anup, are you
yeah,
showing it on the Studio SQL Studio
no, no,
or?
no, 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 no.
Okay, okay,
As of
all
now,
right,
I'm not
okay.
showing it. Yeah.
Yeah, okay.
So, what I want to say here is that, so once you define, I'm just trying to make up a conceptual diagram right now so that I can, when I show it later, then you are able to get it. That's what I'm trying to do. So, so with the foreign key, what we control is that in the parent table or in the base table, whatever values are there, only those values should be created in the child key or the child table, right? That way we can control the consistency of the data as well. How? For example, in the employee table, we have the employee ID from 1 to 100, and then you create another table, which is the employee department table. If you have employee ID 101 there, that doesn't make sense because employee is the base table and it doesn't know which employee is 101. We don't know any information about employee. In the real world, think like that. For example, you have a data, you are just having a company which is actually dealing with the online shopping and all, something like Amazon, right? Then the first thing that you do to what you do whenever you want to shop to Amazon is that the first thing that you do is that you do your registration, right? where you enter your details, like what is your name, what is your address, what is your phone number, what is your email ID, and all that. What happens at that time is that your customer registration happens and all this record goes into the customer table. And Amazon tracks you not by the name, because name can be duplicate. Phone number again is not a good key to get uh, to track. So they will create their own ID, which is the unique ID for each customer, and that would be the customer ID, right? So once they create a customer ID, after that, next you what you will do is that you'll do the shopping. So once you do the shopping, they will they will track that which customer has shopped and which particular products and in when, all that thing. They'll create another transaction table and they will link all those transactions to your customer ID, right? So this is how they can actually easily track, okay, this is the customer, and then accordingly they can give you particular offers and all, right? Based on the shopping that you have done. So now the thing here is that, can anybody do shopping on Amazon without doing the registration? Is that possible? No, it is not possible. Why? Because then Amazon would not be able to track, okay, who purchased this? What is the customer ID for this customer? So the first thing in any such website, wherever you go, is that you have to do the registration. So that registration is required because we want to control the domain integrity. We want to link that which customer actually purchased which order. And this is only possible when we have the information on that, and then we can link that customer ID to the different orders and all, right? So this is where the foreign key constraint comes into picture. So you can't have the customer transaction in the transaction table until and unless that customer exists in the customer table. And suppose that tomorrow, when you are deleting the records, when you are deleting your customer profile, you're deactivating your account, your records would first be deleted from the customer, which is the base table, and then all the linked record in the transaction table would also be deleted. And this is actually with the help of the foreign key constraint. So this is a very important constraint. We'll talk about that again with the example and all. So again, as I was talking about a referential uh, uh, domain integrity, now this is part of the referential integrity as well. Because here, through the foreign key constraint, we are trying to make some references. Referential integrity preserves the defined relationship between the tables when records are entered or deleted. Referential integrity ensures that key values are consistent across tables. If a key value changes, all references to it changes consistently throughout the database. Foreign key and check constraints are used to enforce referential integrity. And the last integrity constant in this regard is the user-defined integrity. So basically, anything which is not defined by Microsoft SQL Server as a constant, that comes inside the user-defined integrity constant. That means when you create the store procedure, when you create the triggers, when you create the functions, etc., you are actually imposing a user-defined integrity constant. You are creating your own business logic, which is not covered in any of this constraint, right? So that is known as the user-defined integrity constant. So let's go through some of the examples of all this. Suppose that this is, I'll drop this table, first of all. Now let me go to the another database that I've created for you guys, which is Bash 266. In this database, first of all, I'll create a customer table. Which has customer ID, int, and this is the identity thing that we were talking about. Name, address, Now SQL Server is a case insensitive language, right, by default. So anything that you write in small letters mean the same thing in capital letter. There are some database languages which are case insensitive, right? For example, the PostgreSQL, right? So there the small and capital letters mean different thing, but here all of this means the same thing. Now here I'll define a constraint. Then I'll give the name of the constraint. Okay, customer ID, primary key, then in brackets, customer ID, right? So this is how, when we are defining the table, at that time, we are also defining the primary key constraint here. That means the primary key of the table. And what I have defined as the primary key is the customer ID column, right? So this is a basic customer table where, again, one of the things that is here that you can see is the identity column that I have defined. What is the identity column? Let's try to understand that. So basically, in SQL Server, we have the options also to actually suppose that you have to insert unique values in a particular column, right? So this is one of the way provided by Microsoft to actually insert the unique values inside a column. So that concept is known as the identity constraint or identity values. In the bracket, you see two things here. So whenever we are going to define the unique values across the column, there are two things we have to give. The first one, is actually what is we are saying is that this is the starting value for this column. That means the customer ID, it will start with value 1, 1, 2, 3, 4, like this. And it will just keep on incrementing with 1. That means 1, then plus 1. So the 1 is the starting value. So whenever we define the identity column, we give two things. The first parameter is the start value, and second was the increment value. For example, if I define identity 2, 3, that means the first value for the identity column would be 1. The customer ID would be, the first value for customer ID would be 2. And then the next value would be 2 plus 3, that is 5. Then 5 plus 3 equal to 8. Then 11. Then 14. Like this. As of now, in this particular scenario, I have defined it to be 1, 1. That means the first value would be 1. Then the second value would be 1 plus 1, 2. Third value would be 2 plus 1, 3. Then 4. Then 5. Right? So this is how we control the uniqueness of record in a particular column. So now the customer ID, I want this to be inserted automatically with the help of this identity. So that's why I've kept it like this. The name we have to insert, the address we have to insert. And then I've defined a constraint, which is the primary key constraint on this table on the customer ID column. Now in this way, I can create a table. Now this customer table is created. The next thing that I want to do here is that I want to create a sales table as well. So I have just copied the thing here. So again, for the sales table, I'll again create the sales ID column, which is again of the type integer, and it is also the identity column. This also I'll create it as a primary key constraint. In the sales table, I can have the customer ID column, which is int, then sales amount, which is money, something like that. Now here, one of the important things that also I want to cover is that the foreign key constraint, right? So as I was mentioning about the foreign key constraint, once you have defined the primary key constraint here, the other thing that I want to define is the on this customer ID, we can create the foreign key constraint. So here I'll say, so this is a name of the constraint that I'm doing right now. This can be any name. It's not like that. I'm just following a way so that foreign key, and then on which column we are trying to create this foreign key. We are trying to create this on this column, and then after that we have to mention the specific thing references. That means this is referencing to which table here. So customer, and then customer which column? Customer ID column. So this is how we create the foreign key constraint, right? When we create the foreign key constraint, then we have to mention for which column we are creating the foreign key constraint. So here we are clicking on the customer ID column, and this is referencing to which particular column? That is referencing to the customer table, customer ID column, right? Now, again, this foreign key constraint can be on multiple columns as well. Right now, it is just one column, but if there are two columns, you can just put comma separated those two columns. And in the same way, you have to do these two columns here. I'll now create this table here. This table is created, right? Now in the sales table, if I'll try to insert some customer ID which is not existing in the customer table, you'll get the error because of this foreign key constraint. So this is what I was mentioning at that point in time. If we want to see that, let's try to see. Insert it to customer values, name and address. See, customer ID would be inserted automatically because we have defined the identity here. We have to just insert the name and address. So I'll enter name as Anup, address, maybe I'll just put Ontario. So I've inserted a value in the customer table. Let me see what value we have inserted. Select star from customer. And you will see that we have the customer ID as 1, name as this, and address as this. Now let me insert in the same way something in the sales table. There can be different format of insert statement. We'll cover in detail about the insert statement. Don't worry about it right now, right? So the first thing that I want to insert is that customer ID, because sales ID will be inserted automatically. Then I'll try to insert the sales amount. Maybe I'll put it like 50. And that's all I need to insert here. So this is also inserted. If I go to the select star from sales, but I'll see that we have the sales ID as 1, customer ID is 1, sales amount as 50. Now suppose that in the sales column, sales table, I want to insert this value, where 3 I'm inserting for the customer ID, and for the sales amount I'm inserting maybe 55 this time. If I go about inserting this one, what we got is that the insert statement conflicted with the foreign key constant. As you can see that now I'm not able to insert this. Why I'm not able to insert this? Because this C customer ID doesn't exist in the customer table. And we have that foreign key constant which is created here. So that's why it's not allowed to have this, because this is a referencing key. So you are not allowed to insert any value which is not there in the base table. I hope this is making sense to everyone. If there's any question, let me know on this. Okay, so no questions.
No, can you please explain that one again, once again? Same thing.
Which this one?
Yeah.
Okay. So basically with the foreign key constraint, what we try to do is that we want to track the parent-child relationship. So parent-child relationship is a classical example, normal in the real world as well. So every child should have a parent, right? So when I define this foreign key constant here, right, this became the child table or the child column for this parent. So this is the parent table here, and this is the child table. Now the rule here is that every child should have a parent. So this is the child. That means this column is the child, and this is the parent column for this, as per the definition of the foreign key that we have defined, right? So what the rule says is that for a particular child row, there should be a parent row. And what we are trying to do here is that in the customer table, we have the customer ID as one only. But in the sales table, we are trying to insert the value of customer ID 3. There is no track of customer ID 3 in the customer table, right? And that's why SQL Server will always give you an error. In the case we are able to insert the customer ID 3 here in the customer table, for example, I insert something like Mohit. I'll keep the same address, and then now again Aisha. So right now I've inserted 3 records, and if you see, now we have 3 customers here, right? And if I try to insert this value into sales table, now this will not fail. It will pass. Why? Because we have a record for the customer ID 3 here. But as of now, like before, when I was running this query, we didn't have any record in the customer table for the customer ID 3, and that's why it was failing. Does it make sense?
Yes.
Okay. So let me now try to insert this, and you will see that this got passed, because now we have the track of this customer ID 3, and that's why it got inserted. Now, one thing that you will see here is that again, after the sales ID 1, we got the sales ID as 3. There is no sales ID 2, while we have defined the identity column as 1 and 1. So we'll discuss about that when we'll cover the identity column. As of now, this is exercise for you to think about this. Why after 1 there is 3? We'll discuss more once we'll talk in detail about the identity column. Now let's talk more about the commonly used constants in SQL Server. So the one of the commonly used constant is the not null constant, which actually takes care of having the not null values inside the columns. Then we have the default constant, which actually takes care of having a default value for a column. Then we have the unique constant, which make sure that on whatever column or set of column you have defined the unique constant, there will have a unique value across the whole table. Then we have the primary key constant, which will make sure that there's unique value across the whole table. Anyone knows what is the difference between the unique key and the primary key? This is again a classic interview question, which is asked. Any idea anyone has? Okay, let me explain. There's just one difference between unique key and primary key. The difference is that unique constant allows one null value, right? On whatever column that you define the unique constant, there can be one null value. But whenever you define the primary key constant, then in that case, there'd not be any null value in that column. So that is the major difference between a unique key and the primary key. Then we have the foreign key. We already talked about foreign key in detail, right? So it uniquely identifies a row record in any other database table. Then we have the check constant. Check constant controls the values that can be there in a particular column. Then we have the indexes. Indexes are used to create and retrieve data from the database very quickly. So that is the purpose of the indexes. Let's talk about them one by one. So by default, any column can hold null values. For example, the table that I have defined here, I have not specifically mentioned that how the sales amount column should be. I have not told SQL Server that it can hold null value or it can't hold null value and things like that. So if I have not defined by default, SQL Server will be like that. Okay, we will allow the um, the null value for this column. But if I want to control that thing while defining the table, either I can do that while defining the table or I can do it after that as well. For example, I can define it like not null. Once I write that, now after that, if you don't give the value for the sales amount, whenever you are inserting the data, that insert will fail because we have a not null constant now in that column. So that is the meaning of the not null constant. Now, another thing that is important for us to understand is that null doesn't mean no data. Null means unknown data. So always don't get confused between no data and unknown data. Unknown data means something which the system doesn't knows that about that data. That is what is the unknown data. Null data is something which the SQL or the system actually like. So null data is something which is actually unknown to the system, right? So that is what the null is. So null is not doesn't means no data. No data is separate thing, but null is separate thing. Null is also null does it only means that this is unknown to the system. That's what just understand by null. So null you can say that this is a placeholder or something which is unknown to the system. Next is the default constant. So default constant will actually it takes care of the default value to a column. We'll see with the example later on. But as of now, just understand that sometimes what we want is that if we are not inserting some value for a particular column, we want SQL Server to take care of that. So in that scenario, we define the default constant. For example, suppose that you have a column named gender in your customer table, and by default you want to insert the gender as female. If somebody is not inserting any gender for them, you can just you want that in that case you have to insert the gender as female, something like that. So you can do that using the default constant. So if in any case people are not inserting their gender, by default you'll take care of that and you will insert the gender female with the help of the default constraint. Next is the unique constraint. Unique constant prevents two records from having identical values in a particular column. Unique constant can contain only one null value. So that is also the difference between the primary key constant and the unique constant. Unique constant allows one single null value while the primary key doesn't allow any null values, but both all prevent two records from having the identical values in a particular column. Primary key. A primary key is a field in a table which uniquely identifies each row record in the database table. Primary key must contain unique values. A primary key column cannot have the null values. A table can have only one primary key, which may consist of single or multiple fields. I think I have already explained why a table can have one primary key, but let me explain again why a table can have only one primary key. This is another interview question which is asked a lot. So a table can have one primary key because whenever you define the primary key on a table, for example, in the customer table that we had created, we had defined the primary key on the column customer ID. So when you define the primary key, what SQL Server does is that it will again store the data physically as per what you have defined the primary key in the table. For example, we have defined in the customer ID. So it will store physically that whole table data again as per the primary key column, and it would be sorted as per the primary key. For example, here for the customer ID, we have the customer ID like 1, 2, 3, 4, 5, right? So it will sort the data in that order, and then it will store again that data physically somewhere, right? So that next time when you are trying to get the data through the primary key, it's easier for SQL Server to give you back that data. It would be actually faster, a lot faster than without having the primary key. So that's why when we create the primary key, a cluster index gets created inside. And that cluster index is nothing but it's like creating a physical copy of the data. Now, once we have defined the primary key, right, and we have sorted the data physically on the primary key on whatever column that we have defined. So can we have sorting, same level of sorting on multiple columns together? No, we can't have. What I mean to say here is that, for example, what I said just now is that when you define the primary key on the table, the data is physically sorted and stored and as per the primary key column of the table. Now suppose that I have already defined the primary key on the sales ID column. I want to define now the primary key on the customer ID column. So when I define the primary key, SQL Server will physically sort the data on the basis of that key column. That is what will happen, right? So if I have already sorted the data as per the sales ID, the customer ID sorting would be different. Every column will have different data set and it will have the different sorting. And that's where it will violate the rule for the primary key. And that's why we can't have multiple primary keys in the table, because when you sort the data on the basis of that column on and you store the data, that sorting value would not match with another sorting value. And that's why we can have just one primary key across the table. And primary key can also consist of multiple columns, right? So that is known as a composed primary key. The foreign key already we have talked about, that this is a referencing key. It is used to link two tables together. It is a column or a combination of columns whose match a primary key in a different table. Then we have the check constant. The check constant enables a condition to check the value being entered into the record. If the condition evaluates to false, the record violates the constant and it is not entered into the table. So check constant is just like, as I said, that checking the value. For example, you can restrict that what can be the particular age of the employees, right? So in the employee table, suppose that you are tracking the age and you want the age of the employees to be greater than 18 and less than 60. So if you want to put something like that, then you can put a check constant there, that age greater than 18 and less than 60. And in that case, if you're trying to insert the employee age less than 18, SQL Server will throw an error. That means this is not allowed to be stored in the database, right? So this is the purpose of the check constant. Last but not the least is the indexes. The index is used to create and retrieve data from the database very quickly. Indexes can be created by using single or group of columns in a table. When an index is created, it is assigned a row ID for each row before it sort out the data. Proper indexes are good for performance in large database. Basically, indexes are, as I mentioned previously as well, it's like the index of a book or index of a dictionary, so using which you can actually access the data fastly or very quickly. And but again, you should avoid creating a lot of indexes in the database, because whenever you insert data into the any table, if we have a lot of database, if we have a lot of indexes, what will happen, that each of these data insert has to go through those indexes as well, and then the insert, update, delete statement will take more time. So that's why be mindful of creating indexes and understand the implications of whatever you are doing in the database. So we'll talk about indexes in detail later on. If you're not getting my point here, that is totally fine. Let's not worry about that. Okay. As of now, just understand is that index is something which is used to create and retrieve data from the database very quickly. That is the whole purpose of indexes. Any questions so far before we end the class?